Well, they have one person, and they only need one person to do that. It's not a big subject.
Is it Martin?
I don't know, because when I went to Manchester, he couldn't make it, so I didn't get a chance to meet him. Okay. B5, so. Fx equals xex minus 3. Show that it has a root between 1 and 1.1. So f1 equals 1 e power 1 minus 3 minus 0.2817, which is less than 0.
Can I just, without calculating, state that e minus 3 is less than 0?
Yeah, because it's clearly less than 0. At 1.1 though, you can't really. Okay, so since fx changes sign, that means there's a root somewhere between 1 and 1.1. Yeah, pretty handy, 3 marks. There was some other question I did earlier today which I was surprised. Yeah, 6 marks for the integration at the end of B3. Okay, the next part is now to find that root by using the Newton-Raphson method. We'll get there, Tal, don't worry.
Is it the derivative over the function or function of the derivative?
Which one do you think it is?
Function over derivative.
It must be that, because what's your goal? To make the function 0, which is impossible if it's in the denominator. Fx equals xex minus 3. Its derivative, by using the product rule, is ex plus xex. So Newton-Raphson's formula in this case would be xn plus 1 equals xn minus fxn over f derivative xn. So here we get this recursive sequence. So we're told to start at 1. Yeah.
Must we add the end?
No, that's just me being particular about my notation. It's fine if you leave it out. I understand what you mean. Whoops. Uh-oh, did something weird here. Plus that e power that. So for when I put in the value of 1 into this, I get x2 equals 1.05181961. And I have to be careful with my decimal places because it really matters for this question. Use it twice. So when I put that at the very end, yeah. x3, if I put that number in, and I'll get 1.0499110606. So therefore, I think the root is approximately, to 3 places of decimal, 1.050. If I look at 3 places of decimal. So the 9 causes the 4 to round up. Well, it's actually 3 places of decimal here, so I should be looking at this one. The 9 causes the 9 to round up, which causes the 4 to go to 5. Okay, so that's part 2. So now on to the B part. So far, that's 8 marks for those 2 parts. Okay, B part. Calculate the volume when you rotate the sine 2x function. So the volume equals pi 0 to pi over 2 sine squared 2x dx. I can use integration by parts. That's what I did with intake 2 earlier today. So I shall use trigonometry formula now. Can I go to the side? So on the side here, you know that cos A plus B is cos A cos B minus sine A sine B. Yeah, so if you want, well, you know what? No, don't write that down. I mean, I'm adding in too many steps. You know that cos 2x is cos squared x minus sine squared x. Oh, hang on, teacher's getting confused. No. Just give me a few seconds. I'm going back to what I had originally. Cos A plus B is cos A cos B minus sine A sine B. And what do I have in the question? Sine, isn't it? Yeah. Cos A minus B is cos A cos B plus sine A sine B. These formulas are in the formula book. If you add them together, you can make a new formula. Cos A minus B, well, sorry, if you subtract them, minus cos A plus B equals 2 sine A sine B. Because, well, I think that's clear enough, I hope. Cos A minus B minus cos A plus B there is there. These two will cancel when you subtract them, and sine AB minus sine AB, well, minus minus is 2 sine AB. But you also know in the formula book that if I now say let A equal B, then you get here cos 0 minus cos 2A equals 2 sine squared A. Yeah, no, this is good. Cos 0 is 1. So 1 minus cos 2A is 2 sine squared A. If I divide by 2, I get sine squared A equals 1 minus cos 2A over 2. Now, let A equal 2x. So this will be 1 over 2 minus 1 over 2 cos 2A. So that's 4x equals sine squared 2x. So that's what I was trying to get to, a formula for sine squared 2x, which I just did. The half minus a half cos 4x. So we can go back to the main question now.
Isn't this longer?
Integration by parts would be...
It is the same answer you get from integration by parts.
Integration by parts wouldn't be longer or shorter. The only difference is integration by parts, you just need to remember one rule, whereas here I've used two rules. Three rules, I suppose, if you count the plus and the minus.
So whenever, rather than integrating, you can just use this.
You can use trigonometry. Now the reason I did it like this as well is because in some years this question would be split into two parts, and part A of the question would be show that sine squared 2x equals this, and then part B of the question would be the integration. So it is actually useful to practice your trigonometry with these questions, because sometimes they make you do it. We'll find a year when it happens. So if I go back to the main question now. Yeah, I can go back. So this here will be now equals pi integrate 0 pi over 2. What is it? A quarter minus a quarter cos 4x dx. That equals pi x over 4 minus sine 4x over 16. You divide by 4 when you integrate. Now, if I put 0 in, I get 0 and 0, so I definitely don't care about that. I'll just care about the pi over 2. Pi over 2 over 4 is pi over 8. Sine 4 pi over 2 is sine 2 pi, which is 0. I lost a half somewhere. Because the answer says it is pi squared over 4, and I got pi squared over 8. 4 times pi over 2 is 2 pi, and sine 2 pi is 0. Pi over 2 over 4 is pi over 8. 0 and 0. Did I use it in the previous? Did I copy it down wrong? Oh, I did! It's a half minus a half, not a quarter minus a quarter. So let me just scratch this out. This should have been a half. So that changes these to half their size. 2 and now 8. And now, so likewise this now will be 4. So this will be pi squared over 4, which I know is definitely right because the question says show that the volume is pi squared over 4 radians. I don't know if radians is the right word to have here, because radians doesn't measure volume. I don't think it should be radians. There's actually another word for when you have radians squared and radians cubed, which I don't, it's some weird Swedish sounding word. Can't remember. But anyways, I don't think it's radians. I think it should be some other word there, but it's not important. Okay, that's B5.